Hello everyone and welcome back to my BPHO video series. In this video, we're going to tackle question 1K from the 2018 British Physics Olympiad. Let's dive in. First, let's read the question. A person might reasonably expect to jump a height of 1 meter on Earth. On a planet with a density 2/3 that of Earth, and a radius twice that of the Earth, to what height might the person jump? Assume that they supply the same energy to make the jump. Let's start by thinking about what happens when someone jumps. When a person jumps, they push off the ground with a certain amount of energy. This energy is initially in the form of kinetic energy, that is, energy due to the motion. As they rise, their energy is gradually converted into gravitational potential energy. At the peak of the jump, their upward velocity becomes 0, and all the energy has been converted. Using the principle of conservation of energy, we say that initial kinetic energy equals gravitational potential energy at the top. Since we are told that the person uses the same amount of energy on both planets, the gravitational potential energy at the peak of the jump must also be the same in both cases. That gives us the equation mass times gravity on Earth times height on Earth equals mass times gravity on the new planet times height on the new planet. The muscle cancels out, so we are left with gravity on Earth multiplied by jump height on Earth equals gravity on the new planet multiplied by the jump height on the new planet. We are told that the jump height on Earth is 1 meter. Also, the new planet has a density that is 2/3 that of Earth, and a radius that is twice the radius of Earth. So we can use the equation for gravitational field strength at the surface of a planet, which is gravity equals the gravitational constant times the mass of the planet divided by the radius squared. Since the mass of a sphere can be written as density times 4/3 times pi times radius cubed, we substitute that into the formula. That gives us gravity equals 4/3 times pi times the gravitational constant times density times radius. This tells us that gravity at the surface is proportional to the product of density and radius. So we compare gravity on the new planet to gravity on Earth using a ratio. Gravity on the new planet divided by gravity on Earth equals density of the planet times radius of the planet divided by density of Earth times radius of Earth. Now plug in the values. We have 2/3 multiplied by 2, which equals 4/3. So gravity on the new planet is 4/3 of gravity on Earth. Now we return to our energy equation. Height on the new planet equals gravity on Earth times jump height on Earth divided by gravity on the new planet. Plugging in G planet equals 4/3 of G Earth. We get the jump height on the new planet is 3/4 times the jump height on Earth, which equals 3/4 of a meter. Therefore, the person would be able to jump 0.75 meters high on the new planet. And that's the answer for the question. Thanks for watching. I'm Physics Michael, and I will see you in the next video.